All right, now we're going to work on a frequency distribution table and see how we can make that, okay? So we're going to use the same numbers that were in lesson 2. Here are the numbers up on the board. There's 20 of them, and that's where you're going to start. So I'm going to give you 20 or so numbers, and I'm going to say make a frequency distribution table. I do have to give you some information. The first information I have to give you is either the number of intervals I'm interested in or the interval size. Now in the lesson, interval size is given to you. Interval size, little I, is 5. We have an interval size. The size of the interval is 5. And that's good. That's a good place to start. That means we have to solve for a number of intervals. And the number of intervals formula is pretty simple. It's just range divided by interval size. So now we're going to calculate the range. And you remember how to calculate range? Maybe not. Range is just high number minus the low number. High number, 99, minus the low number, 51. So it's just 99 minus 51 over I. This equals 48 over 5. And this equals 9.6. Now in interval size, the number of intervals, or interval size or number of intervals, we want to round up, okay? Because we want to be able to include all our data. So this is going to round up to 10. So we're going to have 10 intervals of an interval size of 5. Okay, so this is how I would start doing the frequency distribution table. I would start counting the number of intervals to make sure you have all of them. I would do something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Now what I'll also do in this problem is give you a hint on where to start. I may say start with the lower limit that is a multiple of 5 or something like that. Since we know we want to use multiples or 2s or 5s, a good general rule is take your lowest number, 51, and start the multiple of 2 or 5 right below it. So 50 is a good place to start right there. The lower limit is 50. Now, since we have an interval size of 5, let's remember that 50 to 55 is not an interval size of 5. It's an interval size of 6. Watch. 50, 51, 52, 53, 54, 55. That's 6. So 50 to 54 is an interval size of 5. All right, still with me? Now, to prevent errors, I see this all the time, I would count up by 5s here. 55, 60, 65, 70, 75, 80, 85, 90, 95. And if our top interval, 95, would be to 99, what you want to see here is the highest number in this one? Yes, it is. Is the lowest number in this one? Yes, it is. Do we have 10? Yes. Do we have 5? Yes. So we have the perfect data set that contains all our data. You can fill these in now. This is the easy part. I just look at this one and subtract 1. 89, 84, 79, 74. You got to be careful because you make mistakes all the time. Even I make all the mistakes. 59. Okay? And these are called apparent limits. I'm going to subtract these now for the sake of clarity. That's our first step, finding apparent limits. The next thing we have to do is put our frequencies in. Our frequencies are a count. How often do these numbers fit in these intervals? And you have to do this carefully. That's why I use a pencil and scratch off the numbers one at a time, count how many are in there, and I would double check because this is another easy place to make mistakes. And if you make mistakes here, the whole table is going to be messed up. All right, frequency count. Let's look at our frequency count. So how many in 95 to 99? It looks like there's 3. And then there's 2 in this category, 2 in this category, 3 in this category, 1 in this category, 3 here, 2 here, 0, 3, and 1. I am not superhuman. I have the list next to me. It's easy when you can just transcribe it from the board. You take your time, go through them. Let me show you one other little secret rule right here. It's okay to have a zero frequency right in here, but not here. You can't have zero frequency here or here. If you have zero frequency in either of those intervals, you didn't need that interval, and you don't really have 10. You must have messed up somewhere along the line. Okay, so that's our frequency. Our next thing we want to solve for is midpoints. Midpoints are simply the lower limit plus the higher limit divided by 2. So when we do that, we come up with 97, 92, 87, 82, 77, 72, 67, 62, 57, and 52. Those are the midpoints. Something else we might be interested in is something called real limits. I'm not going to do all of these because it's a bit tedious. The real limits, we just subtract 0.5 from the lower limit and add 0.5 to the upper limit. So this would be 94.5 to 99.5. And you can follow the pattern 89.5 to 94.5. And you can follow that pattern all the way down. Those are called real limits. All right? After midpoints, we want to do something called cumulative frequency. Accumulates the frequency. And what we're going to do is we're just going to add them up from the base. So the entire accumulated frequency in the first interval is just the first interval. And then we add 1 plus 3 is 4. This is the entire accumulated frequency in the first two intervals. 4 plus 0 is 4, plus 2 is 6, plus 3 is 9, and 1 is 10, and 3 is 13, and 2 is 15, and 2 is 17, and 3 is 20. By the way, you want to count these numbers as soon as you can. We know that there's 20 of them, and this 20 right here should equal this 20. You also, as a safety feature, you want to add all these up to make sure your total frequency equals 20. This way you didn't make any mistakes doing the frequencies. All right, let's move on to relative frequency. Relative frequency is simply a proportion. It's a proportion of what's in this interval compared to all the frequencies. So it will be 1 divided by 20, 4 divided by, I'm sorry, it's right here. 1 divided by 20, 3 divided by 20, 0 divided by 20, and so on. So we can plug those in now. Relative frequencies, 0.05, 0.15, 0.0, 0.10, 0.15, 0.05, 0.15, 0.1, 0.1, 0.15. Those are our relative frequencies. We move from here to cumulative relative frequencies. And the same rule applies as we did with cumulative frequency. We start at the bottom. The first cumulative frequency will be equal to the relative frequency in this column, 0.05, and then we slowly add these up. 0.05 plus 0.15 is 0.2, plus 0 is 0.2, 0.3, 0.45, 0.50, 0.65, 0.75, whoops, 0.85, 1.00. Cumulative relative frequency top should be about 1, just because if you add all of these relative frequencies up, they should equal 1. The final one to do is just cumulative percent. This is the easiest one to do. We just take cumulative relative frequency and multiply. We take relative frequency to multiply by 100 to get percent. To get cumulative percent, we take cumulative relative frequency and multiply by 100. So that's 100, 85, 75, 65, 50, 45, 30, 20, 20, and 5. That completes our frequency distribution table. Please follow these steps. It will prevent any unnecessary mistakes.